Welcome back to another exciting chemistry lesson. In the previous lesson, we learned about reaction diagram and we learned how to label different parts, especially in terms of reactant and product and activation energy. Now, in this lesson, we are going to look at in terms of collision theory. So the first thing we know is that in order for the chemical reaction to occur, we need to have enough energy to bypass that hue, right, to pass over it. And we label that as the transition state or the activated complex. Now, another thing we also learned that this right here, as you can see, from the reactant, see that if we look at draw across from the reactant to the activation energy, we also learned that this is for the forward reaction. In most reactions, we see that it's only one way, but in some reactions, there are reverse reaction as well. So what is the activation energy of the reverse reaction? Think about it. If forward from reactant to the transition state, of course, the reverse from the product to the transition state. So this is the activation energy of reverse. And over here, we also drew out the reaction diagram, but for exothermics. And how do we know it's exothermics? Well, that's because it's releasing energy. And when every time you see delta right here, it's always final minus initial, okay? So keep that in mind. And that's the reason why, as you can see here, the potential energy of the product is lower than the reactant, because lower product minus high reactant give you a negative answer. Where over here you have positive, that right there is endothermic reaction. Again, the product is higher than the reactant. So now let's look at the collision theory. Well, we know that molecules collide all the time, but here's the challenge. How do we know that the collision resolves in a chemical reaction? Well, in order for a collision to resolve in a chemical reaction, it must have the two conditions below. Two of these conditions need to be there. First, the collision must have enough energy, and that is, must have equal to or greater than the activation energy. So it needs to have more than potential energy right there, okay? So if it doesn't have enough, okay, no reaction. In order to overcome that transition state or activated complex that we mentioned above, the next condition is that the reactant must collide in an effective orientation, because the molecules or the atoms need to realign themselves to make that chemical bond. If it's not in an effective orientation, you would not have a chemical reaction. Now, let's go in and solve a problem that's very similar to an AP question. So in this case, our task is to draw the reaction diagram. And before we do that, I need to fix that first. This right here is supposed to be activation energy, okay? So as you can see here, we are given the reaction 1 and 2. And the reaction diagram of reaction 1 is shown above. So A and B equal to C. It's already drawn out for us, everything right. The potential energy of reactant in reaction B is also shown right there. Okay, fine. The reaction 2 is endothermics. Ooh, endothermics. That means we have positive delta H. More importantly, we have a higher product, right? Higher than its reactant. That's the key right there. Higher than its reactant. So if that's the case, here's the product, X plus Y. So what we can see here, if that's right there, so we had to go across and go higher. But how do we know? Before we put our pencil there, we need to read more. And the activation energy of reaction 1 is greater than that of reaction 2. Ooh, that's very important, because here is reaction 1, okay? Reaction 2 needs to be lower, so you can put anywhere right there. So as long as not all the way down here, it wouldn't make sense, right? So it has to be somewhere above this line. So it's right there. I put it right there just to make it right there. Okay, so this is 2 right there. That's the activation energy of 2. But here we have the endothermics. For our product, it cannot be above this. So that would not make any sense, because we would need to go forward right there. And our reaction 2 is endothermic. So we have to put the product above here, but below that. So I'm going to put it right here. Okay, that is Z. And all I have to do is just draw over there. There you go. And there you go. You have your reaction to diagram. And that is pretty much it. And as you can see, you have to read it first and then interpret one piece at a time. And it doesn't matter what information they give you, they won't be able to trick you. As long as you take the time, be patient, and dissect one piece at a time. And we see you next time on another exciting chemistry lesson.